So folks, we're continuing with our brief introduction to the Laplace transform. And in this problem, we're asked to use the definition of the Laplace transform to compute the Laplace transform of the function e to the 7t. So let's give that a shot. So in the last video, we gave the definition, and so the Laplace transform of e to the 7t is equal to the integral from 0 to infinity of e to the 7t, that's the function, times e to the minus st dt. And of course, we should probably add provided the integral converges. We need to talk about the integral converging because, while it is true that we can compute the definite integral of any continuous function, and this function is indeed continuous on its domain, this integral is not a definite integral. It's an improper integral because of that upper limit of integration there. So we'll have to be careful with limits. We'll review this more in class, but I'd like to do a quick review of how we handle limits with, or how we handle integrals with infinite limits of integration. So the way we're going to do this is we'll look at the limit as beta approaches infinity of the integral of 0 to the beta e to the 7t times e to the minus st dt. It's an s there. Then I can go ahead and combine the product. Well, I can multiply the two functions in the integrand together. And if I do so, we end up with this, the integral from 0 to beta of e to the 7 minus s t dt. And now we're ready to go ahead and evaluate this limit. So this would be the integral, this would be the 1 over 7 minus s e to the 7 minus s t evaluated between 0 and beta. And I've forgotten my limit there. That's the limit as beta approaches infinity. Great. So now we can evaluate the upper and lower limits of integration. And if we do so, we get e to the 7 minus s beta all over 7 minus s minus, from how we compute by the fundamental theorem, and we have e to the 7 minus s times 0 all over 7 minus s. Well, this, if I distribute the limit, assuming it exists, to both sums, we've got the limit as beta approaches infinity of the first, e to the 7 minus s beta all over 7 minus s, minus this limit as beta approaches infinity of, this would just be 1 over 7 minus s. That's fine. Put that in brackets just since everything else is in brackets. Now, this limit here it's almost not even really worth considering as limit. It's the limit of a constant function, and so it will just be that constant function. So that's going to give me right here a minus 1 over 7 minus s, and we'll clean that up in just a second here. But over here, we've got to evaluate this limit. And to evaluate this limit, we're sort of stuck because we don't know what the quantity 7 minus s is. If 7 minus s is greater than 0, this limit diverges. It doesn't converge to a number, it approaches infinity, in which case we would say that this integral wouldn't exist. Remember, we said provided that the integral converges, that will be the Laplace transform. So that would happen if s, well, let's see here, if 7 were greater than s, or that is, s is less than 7. If s is greater than 7, then what are we saying here? Well, the expression 7 minus s would be negative, so we'd have e to a minus large positive number, so e to the minus large positive number is approaching 0 as beta approaches infinity. So if s is greater than 7, the limit exists, because e to the 7 minus s beta will approach 0 as beta approaches infinity. So we end up with 0 for this term here, provided s is greater than 7. If s is less than 7, then this limit does not converge. And I guess finally, if s equaled 7, then the integrand would have just been e to the 0, which is 1, which also diverges on the interval from 0 to infinity. So we've just shown that the Laplace transform of e to the 7t through this calculation is minus 1 over 7 minus s, which is fine. I'd like to distribute that negative sign to the denominator and rearrange the terms. So that's the same thing as 1 over s minus 7. And we have to add to this, though, this was not the value of the integral in all instances. That is, this integral right here only converged if s was greater than 7. And now we've computed the Laplace transform for the function e to the 7t.